these formulas we're going to use in the future. So I like to write them here. So the sine of theta is going to be always the opposite divided by hypotenuse. I don't want to relate this to any letters like B over C or whatever, because you can call, or somebody in the exercise can call these sides and hypotenuse in your triangle with just about any letters. That's why it's not really that relevant. But when you have a triangle with a 90 degrees angle or right triangle, then you always can see what's hypotenuse and what the angle is and what will be the opposite side to this angle. And that gives you free, keeps you free from calling these sides and whatever with any letters you like, whatever I mean angles. Because in this chapter, we're going to be really concerned with names of angles and sides. And I guess we're going to start out by looking at the story of right triangle, the one we already saw last time. So here's the exercises. And I'd like to do one that will, I guess, utilize these formulas. So just pick one and do it. How about the exercise number just 39 is asking for something. I think I did last time with 2 sides, so maybe I'll do 37 with a side and angle given to us. So again, we're in first section of chapter 8, which is called 8.1. So here I'm going to get the right triangle. We call it right angle is C. So the opposite side to it will be hypotenuse. We usually call hypotenuse as C. And then 2 other angles I can call A and B. So the opposite to B will be the side called B, and analogously with A. So now what they gave us here is a side called hypotenuse, which measured 9. And also they gave us 20 degrees angle. So please notice that making a picture is essential, because we already know that we're dealing with right triangle. So here's 90 degrees. And that's why A and B need to compose another 90 degrees, right? And that's why A is 70. So you automatically get the answer for one of its angles, actually for all 3 angles, using the fact that this is a right triangle. And of course, if you didn't make a picture, you probably wouldn't notice that. And that's why the pictures are very important in this chapter. Drawing triangles is my favorite. So anyways, let us look at the hypotenuse C, and now we need to find A and B. So how can I do that? Well, from, say, first statement, I can say that sine of angle A will be related to the opposite side to it. So whatever it is, opposite, divided by hypotenuse, right? So I need to divide the opposite by hypotenuse. So I'm going to divide lowercase a by C, just like that. And then I can pull out what I need. And I need here, looks like side A. So just multiply by C, sine of A, angle, capital A. And then plug numbers in. So C is 9. And the sine of A will be a sine of 70 degrees. So you don't really have to memorize any of these, but know what sine stands for. And analogously, I could utilize formula for sine of B to find B. Because again, for the angle B, we have here opposite. So this is no longer opposite. It's going to be opposite side to it here for the angle B. So I'm going to divide B over hypotenuse is still C. So I can pull out B and just multiply by C my sine of B. So notice it's the same exact process, but numbers are a little different and letters are a little different, but it's still opposite and hypotenuse. So again, C is 9, and now angle B is measured 20 degrees. So I can put this in the calculator and get the answers. I say, why didn't you use formula with cosines? You have a problem with cosines? I could use it, it doesn't really matter, but then you would use cosine of B, and that'd be pretty much same thing. So instead of using two different formulas, I just decided to stick with one, even though it doesn't matter. So I'm gonna be taking the scientific calculator. Without it, we can't do this exercise calculation. So Decimus. And then we're gonna get a 9. Notice we have to be in terms of degrees. So I go sine, and we are in terms of degrees, right? So it's a sine of 70. And here's the answer. 845, something like that. Okay. So analogously, I can go with the other side. So this will be, again, 9. And now we times it by sine of 20. So when we have formulas, then you just plug in numbers, don't have to think too hard. But you need to know about their existence. Because if you had no idea that there is such a formula, then how would you use it, right? So you need to be aware the formulas exists. We take tests in this online format. I don't limit the time. So on the final, I'll also give you same as much time as for the midterm, but actually not same as much, because after the couple of days, I'll have to submit grades. Or some people are still telling me, "Oh, Alex, I working hard on my midterm. I just been working for more than a month, and this is not going to work with the final because I can't wait for more than a month." So you need to just put things together, catch up, and take it seriously. If you take it seriously, I'm sure you can turn in this exam the same day, because otherwise we'll not be able to do that. So if someone still can't do it for whatever reasons, let me know. I can drop you from class, and so instructors drop, so I can do that. I think we have time until the 9th of this month. So if I don't get any work from some people, that's what I plan to do on the 8th of November. I'll just drop those students from class. I don't want to fail anyone just because there is something not working for you, whatever it is. But I guess it'd be better if you dropped rather than to get failing grade, because that will be on your transcript, and that will lower GPA, and that will give you some issues with standing. So they will put you on probation or something. So that's not pleasant. So I don't think that I want that to happen to anyone. I'd rather just drop, and that be given you ability to start the same class next semester or whenever you're ready, and get a perfect grade and not to mess up your transcript, because that's something that you may not want to have, because if there's a like failing on a transcript, the whole GPA goes down. If you want to go for a 4-year degree, it might stop you from that, and that's why. Well, I just want to make sure that this doesn't happen. That's why I'm warning, and I'm gonna drop those people that still can't get their work sent to me at all. So anyways, I don't do it on purpose. I just drop those students not to fail them. Because after I drop, always people contact me and say, Alex, why did you drop me? Or something. Well, I'm trying to help you, actually, not to give any hard time. So anyways, section 8.2 is using exact same ideas. So they working on any triangle, and they get a right triangle produced from it. Like, for example, figure 19, when we have triangles that they call ABC, so they usually start on the left and go clockwise, then automatically their sides will be lowercase a across A, lowercase c across C, and this is a B here, third side. Now, they're not right triangles. That's why it doesn't really matter how you call those sides, and that's why I told you in the previous section that we have any way we can name their sides. But now I can produce right triangle, and that's the key idea when you want to apply those previously learned things to here. And I can call this as a height h. So I produced right triangles, actually 2 of them, and use these right triangles, I can actually find sides using height h. For example, I can consider this little triangle, and if I have angle C in it, right, then I can find sine of C, because this is going to be a opposite side to it, and A will be its hypotenuse for the little right triangle. So I can say that, again, sine of C is equal to opposite h divided by hypotenuse A, right? And from here, I can pull out height h, because that assumption we're not given. That assumption I utilize to help me. So h is equal to, just like in the previous example, a times sine c. But that's not what I want to find. What I want to find is angle C and side A, so those things that I concern with. And for that matter, I'm going to consider another little triangle here. And again, I have angle here A. Well, I say, Alex, why don't you use B? Well, because B is not given. We don't know what B is. It's broken into 2 pieces. That's why the only angle I can work with is A. And the only side that I actually have that belongs to this green triangle is C. And H will participate because it's opposite. And this is again hypotenuse. Alex, hypotenuse was A. Yeah, it was in the previous case, but now I consider different triangle. So again, I can say that sine of A is equal to opposite, it's still H, opposite to it, right? Divided by hypotenuse by C. So I can again pull out H. It's going to be C multiplied by sine of A. And then, since these two are both equal to H, then I can say that A times sine of C, which is same as H, right, is the same, because it's still H, with C times sine of A. So I found the relationship between A and C, and that H is not really needed. I utilized it to help me. So I just proved so-called theorem of sines that looks like this statement here. In fact, I proved one with A and C. You can write it differently. You can write sine A over A is equal to sine C over C. How can you make sure that this is correct? Well, looks like I can divide both sides of my equation by A times C. So here A will cancel, and I have that side, and there C will cancel, and I will have my left side. And analogously, I can also get same thing with sine B over B, but I need to cut this triangle a little different. And technically, this equation consists of three different ones. So one part says that these two are the same, and that's the first one. The one that we have shows that first and last are the same, and this is the one that we just justified. And finally, there is another, the third part in here that says that B and C also have same relationship, and that'd be our third. So these are three equations that they actually write a shorter way, but I think they should have actually kept three equations, so that'd be better understand. And of course, here's our old favorite statement that sum of all three angles, no matter what triangle you work with, the sum is equal to 180 degrees. So please notice this is all coming from definition of sine as opposite over hypotenuse. I didn't use cosine. We'll use it next time in the next section. But with a sine, we have a standard theorem of sines or law of sines. And I think that's a very nice little theorem that enables us to solve various triangles. To solve triangle means to find all of its sides and all of its angles. So let us try. I just want to start with those cases where we have a nice solution. I say so there'll be sometimes not a nice. Yes, sometimes there are cases when you don't have a unique triangle, but that's something I'm going to look at next time. Today, I just want to get something that already given to us, like say exercise number 9. And to show you that when you have formula, you just plug numbers in. That's really all we do in all exercises of these kinds. So if I'm looking at exercise number 9, and they give us some information here, so maybe I can copy this because it's not much room here. So one angle is 95 degrees. Notice this is not 90. It's not a right triangle. The other angle is 45 degrees. So these two angles I call as, since they say A is here, and then they say also side A is here across A, and side B is there, that must be across B, you see? Then B is 45. Then the third angle must be C, and that be the side C. So it always goes uniquely. So it never happens that you have choice, called this angle as B or the other angle. No, they always give you a unique case. So they actually gave you two angles, B and C, and they want you probably to start with finding angle A. And since the sum of all three is 180, then I subtract 45, and I subtract the other angle from 180, it's 95, right? So I subtract 140 and get another angle 40. And I think this is great because we have a good start, right? Another 40. What else they give us here? They give us the lowest side that happened to be called as C is equal to 5. And based on that, I can find the other angles based on what? Well, sine C over C. It's going to be equal to sine A over A. And simultaneously, sine C over C is equal to sine B over B. See, it's the same angle and the same side. So why I need this is because I can pull out A here. So using the proportion rule, people say A is equal to multiply these numbers across C by sine A and divide by sine C. See what's going on here. How come you can do this? Well, if I want to find A, then I can clear these denominators first. So if I multiply, I think I want to get a separate little page here. So I'll show you that how proportion rule works, and looks like in this chapter we're going to have to use it every once in a while. So I want you to make sure that it's clear. So if we have S disappeared, I started to erase on that side and the S disappeared. Nice. So it looks like sine C over C is equal to sine A over A. So if I have this kind of equation, I can always clear denominators because they always bother me. So common denominator will be AC. So I multiply by it both sides. So there'll be no more denominators, but A sine C times C sine A. And from here now, without denominators, I can isolate any letter I like. So if you like A, fine, divide by whatever is next to it, which is divide by sine of C. But I don't want to do this procedure every time because it's annoying. I can just notice that we have produced A, right? Which is equal to C sine A over sine C. And fast way is just to multiply these two numbers across and then divide by the third number because you need to find the A. So analogously, I can pull out the other letter I need, which is B. And this is going to be a product of numbers across C and sine of B, right? And divide this by sine of whatever remains C. So let me find it. For the first one, I'm going to set it up and then put both in the calculator. I think this is faster like that. So C sine of A, and then I need to be careful because they gave me C, so I want not to copy this again, but utilize number 5 instead of C. Sine of A, 40. See, it's a good idea to find third angle first, because when you have these simpler pieces of information, then you can find a little bit more complicated. And then C is 95. So I'll just plug this in the calculator. Make sure I got degrees. And analogously with a B, I'm gonna have a fraction. Again, C is 5. Now angle B is here, 45 degrees. And divide again by same denominator, sine 95, right? So you will get the two other sides, and that's all we need. So let's do it. So actually, it is good enough to solve just one exercise from this group of problems that appears here, because the others will be the same. nothing will be really different. So I'll just do one and then I guess I'll stop. I know that it's been too much and the weather is a little bit different now. So maybe you wanna relax a little bit. I know some people get sleepy when such a weather happens, right? So maybe you will take a nap if you didn't start it yet. So I'm gonna just stop after this and let you enjoy the rest of the day and the weekend. So divide by sine 95. Okay, so we got this all on the same page, these nice formulas. So I got some kind of number 3.22. That's for my first one. So now, how they want us to write these answers? So here's a special convention that says if everything is given in the terms of whole numbers, then when you find the answer, round it to one extra place. So you can put it as 3.2. I say, Alex, I want to keep it as 3226 and more digits. That's fine with me. It's fine. But I think the answers will be given in the back of the book. Their answers. Did you know that? So the answers should be given with one extra decimal place. So let me get B calculated analogously. So my numerator is the same, 5 sines of, no, it's 45. 45, denominator is the same. It's sine of 95, right? Well, it's not hard to enter. I'm sure that by now you already feel comfortable entering your answers. So there we have another one. It's a 3.54. So I guess I'm gonna write down 3.5. So notice that these two sides, well, they very close to each other. Well, no wonder, because the angles are also pretty close. If there be the same angles, the sides would be the same, but notice sides almost the same because angles on the bottom of this triangle are also almost the same. So formula, plug in the calculator, make sure it is in degree mode. Otherwise, if radians you get, then look at the answer. It's going to be completely different. You see, whatever, 6 something, and that one also changed radians. Well, in this chapter, we get degrees because it's convenient with triangles to put it in degrees, not with radians. So, see, they changed a little bit. So anyways, next time on Tuesday, I plan to actually go to the other part of this section, which is going to be something different. See, what different? Well, it turns out that like figure 34, they explain was different. You might be getting 2 triangles. Sometimes this is the case. Sometimes you might get 2 triangles based on the same exact information. Like here, for example, they gave you 2 sides. One is B, that is here. One is C, that is here. But the angle they give is not in between, but the angle they give you is going to be, which one they give you is the angle? I think here is a C or something. That's makes the, if angle is not in between the sides, if that's somewhere else, well, then there is a possibility for another case. So that's what I plan to consider next time, because it'd be too much for today. So I'll let you go. I don't think I give you a quiz now. I think we need to get used to this triangles a little by little. So then we'll have a little quiz maybe sometime next week. We'll see. So I'm gonna stop. Have a great rest of the day. No quiz. And just